Hi, everyone. Thank you so much for joining the second presentation of the Joint Warfighting track. I will now give the floor to John.
Cole, thank you very much. Let me just bring up the presentation here. Great. I'd like to thank everyone who is attending and people who will be watching this. My name is John Lenko. I'm the president and CEO of Xtensor Systems. Our focus is autonomous AI edge control. And as far as a brief agenda, what I'd like to do is talk a little bit about our dynamic AI technology and some of the projects that we're working on and how it can help you. Also talk a little bit about some of the innovations that we're bringing to the AI space, especially from the distributed perspective. Also want to talk a little bit about some of the next-gen applications that we see coming down the road and present a little bit of our technology roadmap where we're going, and of course summarize what we've discussed and some of the implications and some of the things that might be of benefit to you. When we talk about autonomous AI edge control, one of the big things we're looking at is having something that's cost-effective and easy to use. And when I'm referring to that, typically when you're looking at setting up something on the AI side, you're going to need a lot of experts, especially when it comes to doing things and programming things, developing things. And from our perspective, what we have is a system that can be used that's probably 60% to 70% there that you can build on top of. What we have is an integrated software hardware platform. And the two areas that we provide, our first value add is on the software side. We've patented our dynamic AI smart software. And what it is, it's a combination of artificial intelligence combined with control technology. So in essence, what we can do is we can actually go out and literally control things by sending electrical signals, reading electrical signals, taking information from IP type sources, and in essence, taking the place of a person, doing the analysis and providing some very fast resolution. What we also have done with our system is we've built in the end-to-end security, which means instead of having to worry about a potential system breach, the system actually is, I wouldn't say hack-proof, but we've gone through some very lengthy processes to make sure that the system control cannot be taken over by anybody except by the people that are actually authorized to use it. The second part of our system is our hardware platform, which is our exact V4, V5 miniaturized systems. When I talk about miniaturized, what we've done is we've taken something that's typically the size of a mini refrigerator or larger and brought it down to the size of a smartphone using commercial off-the-shelf parts. And what we've done is come with a very sophisticated way of combining the hardware and software to have very, very high performance with that. And what we've done is we've designed a distributed system that is designed for high performance distributed applications. The real value is that our goal is to provide fairly quick user solutions. Again, something that won't take you years to design, but something that can be done in weeks or months. That's really effectively what we're trying to do. Some of the innovations that we've been working on. One of the things we have is that we've spent a lot of time on system agility. By that, I mean our system is software defined, which means as opposed to setting switches, our software can define ports, input ports, output ports, switch from analog to digital. This can all be done remotely. So there's a lot of agility, especially when you're looking at fairly sophisticated ConOps that require a lot of potential changes pre-mission or even during mission where you need to make some changes. Another thing that we're working on too is we have a very flexible architecture. By that I mean we can run hundreds of algorithms versus just 3 to 5. Typically, when you're implementing a neural net type system, there are limitations because neural nets tend to be very processing intensive. Well, what we've done with our architecture, we have the ability to run hundreds of algorithms. Specifically, we have different types of AI systems that we use to combine, and also the way that we load them and store them in memory and call them. So in essence, we have a real-time management system that manages the algorithms, which provides a lot of functionality, which means if you're running missions that have a lot of complex things you need to do, we're probably a good platform to look at. Our performance is also very high performance. When we talk about real-time performance, we're using the NASA definition of 100 milliseconds for real-time. Some people will consider that near real-time, but when we define 100 milliseconds, that's from start to finish. Again, problem identification, problem resolution, that's 100 milliseconds, which is a lot faster than most people can even process information, versus currently doing seconds or longer to solve something. Our accuracy is also very, very high. And the way we do that is we add inference engines to our AI type solution. And what does that do? Well, what it does is it handles the situations that typically go off script. By that, I mean, typically with a neural net, it's very good at figuring out things when you know the parameters and you tested them, you've done a lot of simulations. But the issue is what happens when something happens that you can't account for that you weren't expecting. That's where we tend to shine. And we can provide a more realistic type solution to something as opposed to just coming up with a generic response to something. As I mentioned before, we do have the built-in distributed security, which means that your operations will be secure versus a potential disaster if you try to bolt on security after the fact. Also, one of the things with our system is that we can dynamically modify parameters and fix problems. What does that mean? Well, what we have is we're not what I call a self-learning system where you would turn us on and we would learn everything that's out there, but we're programmed to specifically do certain things. And from that point on, we are self-learning. We will adjust, we will modify parameters, we can talk to third-party systems, make changes there. And based on the environment, we can actually change and adapt to, in essence, become a chameleon that matches in with the environment that you're trying to operate within. We also are self-contained, which means we do not require a cloud or cloud access to operate. We're fully contained. However, we can interoperate with a cloud to provide information after the fact or pull off resources if needed. So there's a lot of flexibility there. I mentioned our size, weight, and power advantage. We literally are, our large system is the size of a cell phone versus a refrigerator size. Oh, to be realistic, it's more of a mini refrigerator, but it's still a refrigerator. Also, a one board solution versus, let's say, 4 to 5 boards, depending on the type of applications that you're trying to do. What's the implication? Well, the implication is if you have, let's say, a UAV and you're trying to run some of these complex AI systems, we could potentially save you 15 to 20 pounds of payload and add some extra space that you can use for different types of missions that you want to run. There's also a lot of customization with much less programming. Our interface is designed to be library-based, which means you're combining pieces of code that are there. And our system writes its own code, which means you don't have to worry about programming it. It basically writes it. And really what you're doing more is configuring it and matching your mission to what you're trying to do. Let's talk about some of the next-gen autonomous applications that we see coming and that we're working on. The first one, we actually are currently working a U.S. Navy Phase 1 STTR to develop an autonomous mission planning system for NAVWAR. And the application is for autonomous UAVs. This is a system that we're currently developing and moving forward with, and it's going very, very well. In addition, we were also just awarded a contract by the Space Force, also a Phase 1 STTR, to focus on space debris remediation. And that STTR has 2 components. One, it has a steerable CubeSat, and we also have a space-based autonomous control system. So those are the 2 things that we'll be developing for the Space Force. Another thing too is we also developed a software hardware prototype for an IT/OT equipment management platform. It's a larger rack mount system that if anybody's interested in, we could potentially demo that too. That's not an AI system, but it shows conceptually what we can do and add an AI system on top of that. Also, one of the things we'll be expanding into will be the IoT and IIoT markets. In essence, what we have is software that fits into these markets very, very quickly and easily. And with our hardware, we can easily provide a machine-to-machine interface. Our system also is designed to handle encrypted communications. That's another application for us. Also, our initial application is for UAVs, but the system is designed really for autonomous vehicles. And it doesn't matter. The autonomous vehicle can be a car, it can be an air system for the Army, it can be a ground system, it can be a sea vehicle. It can actually be an autonomous satellite, as you see for the Space Force application. It really doesn't matter. The difference would be the hardware application, but the software with modifications would be fairly close, with the exception of the libraries that need to be developed. Another application is also autonomous equipment management and maintenance. Also, hypersonic flight control. We've been doing some work in a hypersonic and also for subsonic applications for anti-laser systems. But with the possibility of using that product and adding it on top of the control system, it is possible to put it into a hypersonic vehicle or a hypersonic device of some sort and provide a hypersonic flight control. Also, autonomous robotics. One of the things we're working on is our system is designed to be distributed. From the autonomous robotics side, we've been doing some early work on the chip side to develop a localized chip that can actually take the distributed systems and, in essence, internet with them. So conceptually, what we can do is take our system and put it inside some type of robotic system. And in essence, we would have an autonomous robotic system that's internet worked. A bit of our technology roadmap. A part of the fallout is initially our focus is on the UAV side. So flight navigation, flight control, both from the hardware perspective and software perspective. Also from the UAV side and also with the Space Force STPR, also a space application. Secondly, we're also looking at taking our technology and leveraging it into the industrial control market, which is a fairly large market, approximately $100 billion market. We believe the autonomous portion of that market is closer to about 20 and 25 billion. And what we have is a core software architecture that we can leverage and of course take our hardware products and leverage that into new types of products for this market. The third market that we're looking at, and this will be the final offshoot, will be the autonomous robotics market that I mentioned. What we've done is we've already developed some early prototype designs for the chip that could potentially tie our systems together that can be applied to the robotics portion of the market, and with the development of very specific robotic controllers, both software and hardware. In summary, and this is our last slide, we see ourselves as an integrated first-to-market solution, sort of like, to use the high-tech definition, kind of like the Microsoft Cisco for next-gen autonomous AI. We expect this next-gen autonomous AI system and solutions to be introduced in the next probably realistically 2 to 4 years, possibly 2 to 5 years. So what we're working on is a ground floor technology that we believe could potentially revolutionize this portion of the industry. We're also looking at a very low cost type application, relatively speaking, and something that's easy to use. Literally, it's the PC to mainframe analogy. So instead of going out and buying somebody's proprietary hardware, proprietary software, we're trying to make it more open where you actually have a platform. You can very cost effectively get into the market, get into the applications, make some modifications, and do some things that could potentially work a lot easier. Our biggest advantage that we see is a high productivity gain. Let's take the UAV example. Instead of what a lot of people don't realize are that UAVs currently have a one-to-one relationship, which means you have one pilot to one UAV. In the UAV example, we're looking at taking potentially one pilot, or instead of having a team of pilots, actually having one person potentially managing a swarm of UAVs or multiple UAVs. Let's throw out a number 10. And instead of having a team doing that, have one person potentially managing it, it's more overseeing it. The systems will be running their missions autonomously. And instead of having a team 24/7, you could potentially have one person and missions can be run and can be done a lot more effectively. And missions can be run 7 days a week. And you get a lot of scalability, a lot of productivity. Take this and take that into the industrial market where you're trying to do things where you have people managing and doing things, managing equipment. Again, instead of having an army of people, you could potentially have humans doing things more efficiently and also having machines manage things where you don't really necessarily need a human in the loop except from a supervisory control, if you even need that. We see our technology as being very complementary. Again, it's an autonomous technology. Think of it as next generation automation, where we run things autonomously, where we can adjust things and do things and, in essence, alert people if there are problem conditions or things that are out of bounds. But we see this as being very complementary. It's almost like an aftermarket type product where you're running a system, you need to improve it. Now you have an AI aftermarket solution that can actually be installed in with your system, whether it's distributed or whether it's just a single system that's out there, and make it more efficient, more effective. We see multiple new large markets out there. Literally any single market that needs a lot of people, where you need to leverage things, we think those are markets that we can potentially help develop. Also, we have a fairly scalable solution. What we've done is we've actually built in a language interface, which means that you can actually change the languages that are being used. And this is something that we learned from our work with Oracle Corporation. About 50% of their customers buy their product because it can be localized. So from our perspective, our solution can be localized too, which means if you want to see a solution in English, you can see it in English. If you want to see it in Japanese, you can see it in Japanese, depending on which kanji character set you want to use. Or if you want to use it in another language, we'll accommodate that too. It's virtually unlimited. And finally, we are looking for partners and projects. So if you have any interest or if you'd like to discuss things with us, we'd be more than happy to speak to you, find out what you're trying to do, seeing if there's a potential fit. And as I've mentioned, so far we're working with early adopters like the Navy and also the Space Force. We're looking for next-gen solutions that they can deliver sooner rather than later. Thank you very much for your time.
John, thanks so much for the presentation. If anyone in the chat has any questions, feel free to post. And we will be around for another 3 minutes. But other than that, we'll have the next presentation at 10:20. Give it another 30 seconds or so. All right. If there are no questions, I want to say thank you to everyone that attended this. Thank you, John, for presenting all of that. And we will see you guys back here at 10:20 for the next presentation. Thank you all.
Thanks, Cole.